In order to calculate the function cosine efficiently on a small computer, we first notice that it is a symmetric and periodic function. This allows us to limit the range of accepted values that need to be accurate in our computation. From there, we can use the Maclaurin or Taylor series approximation technique to find accurate values for inputs close to zero. This method uses the properties of the derivative to create an approximation that becomes more accurate the more polynomial terms you use. For cosine, just one term gives a constant expression. 2 terms is still not accurate enough for our bounds. 3 terms gets very close but gives noticeable error at pi over 2. And 4 terms becomes almost exactly correct on our bounds, so this is the length term we will use. When implementing the formula on the propeller microcontroller, we run into a couple issues. First, that we can only use integers and any decimal points are cut off. Second, that all numbers in each step of the calculation must be smaller than 2 billion. By multiplying the whole function by 1,000, the result becomes an integer representing 3 decimal places of cosine. In order to keep the number as precise as possible, while smaller than 2 billion, we make use of the associative and commutative properties of multiplication and division. When that code is ran on the microcontroller, you get a list of values. When compared to the value calculated by Excel, you can compare them through subtraction to find the integer error, which is mostly zeros and ones. At a couple of locations, you get an error of 2. This happens at 54.1 degrees and 60.3 degrees.